back to my Astro Imaging Journey channel. Today I'm going to go over my workflow for PixInsight. I have I believe around 8 hours of 1 minute subs. That's what is that, about 480 1 minute subs for M103, an open star cluster. So I want to go through my process. I've already sorted through some of these, but I'm going to go through my process of using PixInsight and my workflow, and hopefully this helps you guys out. This is going to be my first test on a full set of 8 hours. That is my goal of getting 8 hours per target. So with that, let's get into it. Okay, so on the screen now we have M103. This is approximately 5.5 hours worth of data, stacked, processed, the whole workflow used. I want to see if I can improve it now that I have over 8 hours worth of data. Maybe, maybe not. We'll see. I can see some of these stars are kind of blown out, so we can see if we can improve that some. But overall, I like this image. If I zoom in, you know, the noise is smoothed out a lot. You know, for my first attempt with any target that had more than an hour or two's worth of data, I kind of like it. So let's see if we can improve it a little bit, and yeah, let's get back at it. And all the way down here, I've sorted by date. We have M103, and it looks like around 100 or so. So the first thing I'm going to do is I'm going to go to my desktop and I'm going to pull up my, where is it? There it is, my workflow document. And as you can see here, it's just a simple Word document. If you're using something else, that's great. Just scrolling through here, you know, we got about it looks like 12 steps. Let me fix that. And yeah, so it's just a simple document. Most of the stuff is in my head, but it's some good references. And for example, when you got to input the image parameters, since the image train is pretty static, I know that it's a 3.72 for the scale and 1960 for the focal length. So just some little notes to help me get started. So for example here, select 5 stars, 20 is preferred, and you know, they should be between a 0.8 and a 0.2 amplitude, and I'll get into that later. So I've got my document sitting here, and apologies for the, sounds like Kobe's barking at something in the front yard. So the first thing we want to do is blink, or at least the first thing I like to do is blink the images I took. I'm looking for elongated stars, severely elongated stars, tracking issues, meteors, satellites, airplanes coming across, things of that nature. Once I remove those from the image set, then I'm going to go zoom in and I'm going to look again, this time looking for focus issues. So let's open up the blink module. Actually, the first thing I'm going to do is I'm going to come over here. I have a process icon set. Okay, now let me back up for a second here. A lot of this information that I have comes from various channels that I've compiled into one set that's working for me, at least working for me at this point. That came from Astro Dude, came from Richard Block, came from a couple of presentations on the astroimaging channel. All these sources are great for information, so please go check them out if you can, and watch a lot of their tutorials. They'll get a lot more in depth. They'll do some explanations on what these modules are doing. They're just great sources of information. They, especially the guys on the presenters on the Astroimaging Journey channel, or excuse me, not the Astroimaging channel, TAC. They bring on subject matter experts, the guys that either wrote books or, in some cases, actually wrote the software to come in and explain different things. So it's great information. Again, Astro Dude has a nice set of tutorials, goes into some detail on what each one does and what it's used for, and it's great sources of information out there. So I'm going to try not to rehash a lot of that since it's already out there. But if I do, please forgive me. So I have here loaded my process icons, and as you can see, use blink, image scoring, batch pre-processing. If I go back to my document, blink, image scoring, batch pre-processing. So I've set up these process icons roughly in the way that I'm going to process my images. It kind of helps with the workflow. So with that, let's get into the blink module and we'll go on. Now if you notice, it says S for script. That means I cannot just double click on this. It's going to bring up this little window, and I can't do that. So you would think it's a script, so it should be under script and blah, 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 but it's not. It's actually under process now, and I like to go to all processes. Some of the other guys like to go into the categories here, but I like to go into all processes because I kind of know where things are, and blink is right there, so let's bring that up. Now I need to import all of my images into there, so I'm just going to move this over here real quick. Down here we have the folder icon, add image files. So we're going to go, and if I had been in a different folder, it would have displayed there, but I am in my SGP data folder with focal reducer subfolder. So I'm just going to highlight and select all of my M103 images. That was just selecting one, selecting the bottom one, holding shift, and then clicking on the top one to select all of them, and then open. And this is going to take a couple minutes. Luckily it's locally on the it's on a local hard drive, so it won't take as long if I had it on my storage server. So we're going to let these open and then be back in a minute. While this is processing the images, just want to explain something. The reason I moved this off to the side is so that I can watch the process console. I believe by default it comes up over here in the upper right, but I have moved it over here to the upper left, and I have moved it to the lower right. Just because with the workflow and the process icons, I like it to be over here, just so I can watch what's going on and it not be over my images and things of that nature. If you noticed, when I took my mouse away, it will go away on its own. I believe there might be a way to have that static there, but then it kind of gets in the way at times. So just keep your mouse over the window and it'll stay there. So just waiting for it to finish up. All right, and here we have blank calculating statistics is done. So that's the message we want to see right there. So now we're going to come back over here. I like to move this over. And don't worry about this being grayscale. It is that way by design. And if I hadn't already, I would have clicked this little zoom to fit icon here, simply because they like to open up a little bit smaller window, about 2/3 the size of this. And being that I'm a little bit older and do have to wear glasses, I like to have the images as big as I can. So at this point, I will set this little timer to 1 second. And then I will hit the play button, which I'll do here in a second. And what that does, and again, I know I'm diving into some of the details that I said I probably would try not to do, but I think it's good to understand my workflow and why I'm doing some things. You know, I could just step through, clicking the arrow, but what I like to do is just let it play, and I pick a focal point. So usually in the middle. I do like to hunt, so I am used to staring at one area, in this case where my crosshair is, and using the periphery. I'm not focusing so much on the crosshair as much as I am concentrating on the periphery and looking for something to change. And then, so where the crosshair is where I'm going to focus my eyes, but I'm going to concentrate on the outer edges. And then I'm going to keep my hand on the mouse and the mouse over the play animation button. And let's let this cycle through. And all I'm doing, you'll notice it is getting a little bit brighter. That's because the moon was coming out. So I'm getting a little bit of bleed over. Now it's looking like a lot of bleed over. Okay, so that's one of the reasons why I like to keep my finger on the mouse and the mouse on that animation button, simply because then as soon as something sticks out, I can click it and stop the animation. As you can see, it got very washed out between the two frames. So we just step back and forth, and yes, that is way washed out. So with that one highlighted and displayed on the screen, I'm going to come down here to the window with the red X, close selected image. I could uncheck it, but the reason I'm doing this is that it removes it from the panel. Okay, so we're going to close that one out. It goes to the previous image. Let me step to the next one. Okay, still a little washed out, but not as bad. So we're going to start the animation again and see if we find another one. And there's another washed out one, so let's remove that one. Okay, so it looks like we've had several washed out ones. So what I can do in this case is go to my next one. Yes, it's washed out. So I'm going to uncheck box it. But I'm also going to remember this is 002557. Okay. And I'm just going to step through, and you can see why it was washed out. We had some clouds. You can kind of see the banding in here on the left-hand side of the image. Some clouds moved in. All right, so I'm going to uncheck that one. Let me go back to this one, 002557. And then I can hold the shift, select both of those, or all four of those, and then use this double window with the red X. That is close all images. We do not want that one. Be careful. We want to just remove the selected images. And just like that, they're gone. So now we're going to play the animation again and see if we can find some more. Alright, so let's get rid of the last set. Okay, now that was the overview. Again, I'm not too concerned about the whitewashing. I have plenty of data that is darker, and the severely whitewashed is definitely an issue, but most of that should get averaged out, especially after 8 hours of data being collected. So now I've gone back to the top. This was my 1,000-foot or 50,000-foot overview. So now I'm going to zoom in, not real tight, but tight enough. And what I'm going to look for is out of focus stars and elongated stars. Severely elongated stars. Like this one looks a little elongated, but they all look to be pretty decent. And then you can see here where my crosshairs are. Looks like I have some hot pixels. There's 3 of them right there, maybe a 4th. But as I play the animation, you may have seen in the other, with it zoomed out, the stars are moving around. I am using dithering, so those will definitely get averaged out in the end. So I'm not overly concerned with those being there, but if I start seeing way too many of those, maybe time to get a new camera. So let's play and see if we find anything. As you can see, something happened with tracking here. You get these double star looking things. That's why I like to zoom in, because I didn't notice it in the other view. It would probably get averaged out if I left it there, but I have plenty of data, so I'm just going to go ahead and remove that one. Now, if you notice here, I'm looking at, see how the stars get bloated? That's clearly clouds or a seeing issue, so I can remove that one as well. All right. So now we have all of the frames that I don't like removed from the list. And this is why I remove them, or I clear them from the list. Because now I can go in and select the first one, scroll down. I haven't had the greatest luck using the scroll bar and keeping the top one highlighted. For some reason, it may just be a display bug. So I use the old scroll bar here on the side, go to the bottom, select them all, and now I want to move. So it'll be this little folder and file icon with the arrow. Move them to a new location. Now I could copy them. I could use this copy here, the little floppy disk icon, copy. But since I'm putting these on my storage server, I'm just going to go ahead and move them. So then we go up here. So my storage server, it's my network attached storage, Astro Imaging, targets with focal reducer, M103, T6i, 1 minute subs, ISO 1600, and blink good. So all my originals, if I had just pushed them up there, I was going to do a blink at a later date and time. I would put the originals right here, and then I would blink them later. Once I do blink them, I move them into this blink good, so that I know that these I've looked at, I'm 95% happy with them. Some of these are a little washed out, but I'm going to consider them good for now. So we're going to select the folder, and I should have moved the blank module off to the side, but as you can see, it's moving 86 files. And once that completes, we will be back. All right, it disappeared, so let me just move this over. Move it over some more. And yes, it's done. If you noticed, I kept my cursor over the window so that it would stay active. And then once it completed, it moved. That's my indicator that it's done. So now I'm going to come over here, and I'm going to close all images. This wipes that clean. So if I decided to go in and so let's look at what we have here. SGP, as you can see, I have NGC 4147 and 1502 and 457. So there's some other targets in there, so at this point I could blank them all and individually per target and move them, which is why I like to clear it out. Also, the next time you do load this, it does save those settings. So if I had left those in there and then closed PixInsight, came back 2 or 3 days later, I'd still have to close them out. So it's just part of my process to clear it, so the next time I open Blink, it's a clean slate. Now, before I move on, I want to explain why I use the NAS. So, yes, it is great to work off the local drive. I do have an SSD drive, so it's extremely fast. And then another terabyte secondary hard drive in here, which is where all the data gets stored to during the imaging session. So could I store everything on here? Yes, I could. But as the targets grow, I need more storage space. And instead of having a ton of external drives and trying to remember what is where, in preparation for this, I purchased a NAS. So let me go to, and I then mapped it right here. Okay. So the partition I'm using, which is for me, is a 9 terabit partition. And as you can see, I'm using roughly 1.5 terabits of data. Now that's video I've taken. That's drone video. There's cell phone video, all different types of videos, pictures, music. I have a bunch of, because I'm older school, so I have CDs laying around the house. I converted them all to MP3s, some general storage that I need to sort, games I had purchased, digital downloads, documents. So every, 1.5 terabit roughly is being used. And if I go in my Astro Imaging, which as you can see, I have my calibration libraries, which is my darks, flats, biases, as well as my targets. That, if we go to properties, let it count up here. Okay, so it's finished calculating, and it says it's 271 gigabytes worth of data just in this folder alone. Could I fit that all on a 1 terabyte external hard drive? Of course I can. But with the NAS, this particular NAS, it's a Ready NAS from Netgear. It has 6 3 terabyte hard drives in it, and they are in RAID 6 configuration. So the nice thing about that is, if I just put everything on an external hard drive and that hard drive failed, I lose all this data. I lose all this time, and that can be very frustrating. It's happened to me in the past. And using the NAS with a RAID configuration, the data is actually replicated. So if something happens to one of the hard drives, I can swap it out, and then it'll rebuild the data that was on it. So it has 18 gigs of total disk space, but because of the replication that goes on, there is 13 gigs usable, and of that, for my use, I have partitioned off 9. Did I say gigs? I'm sorry. It's 18 terabytes worth of total space, 6 hard drives at 3 terabytes apiece. With the RAID configuration, obviously, it's got to strip some of that away for the replication, which gives me an effective 13 terabytes worth of space. And of that, I cordoned off 9 terabytes for my use, and then my kids have a couple folders. My fiance has a folder. Everybody has a certain quota they get out of that. And if we need more space, swap out a drive, increase the space. It's not quite that easy, but it's easy to upgrade at that point. So this particular NAS I bought can handle 12 terabyte drives, so that's 6 by 12 or 72. And then on top of that, I can use 2 expansion chassis to increase even more. I won't say I'll never use that much space, but it's going to be a long time before I need to upgrade this thing. So I did go a little bit bigger and a little bit more expensive when I bought it, but it gives me growth going into the future. So with that, and then for now, I leave everything right there. So the next thing we're going to do is get into the image scoring. So that's the second one in our process here, and it is the second in our workflow. And I want to find a reference image, and I want to prepend it with REF for reference with an underscore at the beginning of the file name. Literally, that is what I'm looking for. I'm looking for a few outliers maybe, but by and large, I'm looking for that reference frame. So let's go into script, batch preprocessing, and subframe selector. And again, if you look over here, it's an S icon. I can't actually load it from here. It's just a placeholder for my process flow. So I'm going to go in here, and let me clear all those out. And let me add the files. But before I do that, let me go back into my folder, simply because I like to keep my data clean. And these did not get moved over to my NAS. This is what my SGP stored directory, where it dumps everything during the sessions. So these did not get moved. I considered these bad, so I'm going to go ahead and delete those. So now I'm going to point over to my NAS, and yes, my directory structure can be a little lengthy, but it helps me keep things in a way that I understand. So this is anything related to astro imaging. These are going to, all my targets, all my data is going to be underneath that folder. I had some data before I put the focal reducer on. So now I have a with focal reducer folder, my target, camera, how long was this individual frames, and at what ISO. So if I went over to here, you might see, as you can see on M27, I tried 2-minute and 5-minute frames with an ISO of 800 on there and a 1600 on there. If we go to our calibration, you'll see the darks, camera, various lengths, and ISOs. And underneath there, when I took those. I do need to update those, which I'm going to attempt to do for now for this particular tutorial. I am going to use these, but I will be updating those in the near future. So let me go back into here, my focal reducer, and obviously I don't have anything here because I've blinked all of the images. And here is all the images I consider good. Select the first one, Control A in Windows to select them all, and open. And let's move that over here. System parameters, I leave these as default. Yes. Subframe scale. What you can do is get that from SGP. Go in there, select any one of these images, do a plate solve on it, and it will give you your rotation, your scale, various things. So I will be showing that in the SGP tutorial video, which I should have already uploaded. And I guess I should take a note here, but it's knowledge. So that's pretty much the only thing I update there. Star detection and fitting, I leave these as all default. Expressions. Now, what I did put in here, and this was a suggestion from, I believe it was Richard Block's video, 2 times the SNR weight. The SNR weight is a value. If you come in here and you do edit, you'll see a bunch of the values you can use. SNR weight is one of them, as well as full width half max. So 2 times the SNR weight minus the full width half max. And that gives me a plot down here. Okay, and I'll go into that so in a little bit. Table I don't worry about. There's my plots, as you can see. You can select a bunch of different things. The weight is where this expression comes in. And, you know, the graph will plot the numeric values here, and then the images across, you know, the number of images across the bottom, and it'll give a nice little graph, and we're looking for the topmost on the graph, which we will see in a few minutes. And then output, you know, a lot of people I know, and in those tutorials, they'll use this to remove bad images and different things. I'm not that concerned about it at this point, since this really is the first image I've gotten around 8 hours of data collected, and it's a star cluster, so we're not too overly concerned with structure and nebula and all these other fine detailed things. So for this instance, I'm not going to play with, you know, put in a postfix of an A or an X and all these good things. I just want to make sure they're all within a certain range, and which we'll see on the plot, and I want to try to find one of the highest value images to use as my reference. So with that, we're going to come down here and do a measure. The window closes. Now, this will take some time to run simply because the data is up on the NAS. Could I take those images, move it to my SSD, and then do the measure and all that jazz? Yes, it would be faster from a processing standpoint. It doesn't have to go to the NAS, dump a copy to memory, process it, remove it from memory. But as you can see, it's going fairly quickly. The total time it would take to copy it to the local hard drive would be right around in the same realm of time frame as it would just leaving them up there and letting it do its thing. It's just one less step to have to worry about. It's not doing anything to the files on the NAS. It's just making a virtual copy into memory, processing the information, and then clearing it from memory. So there's no threat of it impacting the data itself. So we're going to let this run, and when it is completed, I will be back. All right, looks like we are done. That definitely took some time, looks like nearly an hour. So here we have our plot. Looks like most of the values are going to be between -4 and -7, that looks like. Got a couple, some that are down. Those could be those washed out images. But we were mostly looking here for this guy right here. Unfortunately, I don't know how to actually know which one of these it is. So I kind of just have to say any one of these would do. So we're looking at, let's see, 300 to 400. 1, 2, 3, 4 ticks, so each one is about 20. So this one will be 40. So 340 would be that one. 39, 38, 37, 36, 35, 335. So we look up here in our subframes and we scroll down to 335. So we're looking at 8 Celsius on the 18th, 195040. Scroll down here, 8 Charlie on the 18th, 195040. So that would be this guy right here. We'll do a quick rename and to the reference frame. Let's just make sure we're still, that looks like one of our better frames. So we're going to dismiss this now and open that up real quick. I should have cleared that out, but that's okay. So just double click on the desktop. We're in that folder. There's our reference frame. Do a quick stretch on it. Not the darkest, but that is pretty well centered. Decent stars. So that will be our reference frame. And next will be batch pre-processing. We will get into that after I take care of a few other things here at the house. As you can see, it's the day after Christmas. I'm just going to show you how backlogged I am due to work and other things. We've got episode 11, 12, 13, 14, all the way down. I still have yet to record the PhD and SGP settings. And then this one is 19, so that'll probably be 18, 19, 20, 21. So I'm going to take care of a couple things around the house here, do a couple of edits on these to get these uploaded while I've got some time off. And then I will be back later to go through the batch pre-processing. Okay, so the next item that we're going to cover is batch pre-processing. So let's go over to my notes. I don't have any notes, just stack the images. Some people like to go in and manually calibrate and align and do all these things. So far, with the items I've done, the targets I've done, batch pre-processing works pretty well. I could probably get a little bit better images if I were to do things a little bit more manual, but for now, batch pre-processing is working pretty good. So let's see how this works on this one, and we'll go over here, script, batch processing, and then batch pre-processing. Again, it's a script icon over here, so I can't select it from this. It's just a placeholder for the workflow. Now, once this opens up, as you can see, I've got everything cleared out. We need darks, flats, biases, lights. If you're not familiar with these, go do some research. They're all really critical in fine-tuning your final image. The bias is simply a how much noise is on your camera natively. So this is the fastest shutter speed, all lens caps on, it's a dark frame, but at the fastest shutter speed. That will give the software a baseline of sensor noise, just how much noise is in the sensor right off the bat. So let's add the biases. So we're going to go back into my working folder, calibration libraries, bias. I know this is an ISO 1600. If you notice, there wasn't any time, for the subs, simply because these are at, in my case, 1/4000th of a second. So we're going to select all of them. And it should populate here. Yep. So now our darks. The darks, those match your exposure time. So this is going to be how much noise you have over that exposure, over that ISO, off the sensor. Again, lens caps on, dust covers on, whatever. It needs to be as dark as possible. So let's add those. Let's go back up here to darks. Now these are 1 minute exposures. So we're going to go to that one, 1600 ISO. I know I need to update these. These are about 6 months old now, so I do need to update these to more recent, but for now, we're going to go ahead and use them. And now our flats. Flats are tricky to get. There's plenty of information on how to do that out there, several different ways. I use a basically a modified t-shirt style of flat taking in the very early morning hours. I might go over that and create a video, but for now, let's just get these added in. I had to update them after I added the focal reducer because that will change where the dust motes are represented in your image, and that's what we're trying to do. Is we're trying to get some images with some light in it, where you can see the vignetting, on the side, as well as any dust motes that are present, and it'll help draw those out. So let's get these added. And then our lights, let's go down here, add lights. And I've moved those to the local file simply because we have 480 plus. So it'll just help the read time on the files when it's trying to process, so it should go a little bit quicker. And there we have. Now we can go into each one and adjust these, but for now I've left them all default settings. As I get more experience, I'll probably play with them and figure out if anything works better, but for now defaults seem to be working okay. Mosaic patterns, so we will just leave that as auto. VNG, since I'm using a DSLR, the VNG is what we need. Image registration, again, I'll leave these default for now. And under image integration, I leave these as default. If I only had, say, 5 and I was just doing a test image, then I would come down here and select a different one based on a recommendation. So if I go now and say diagnostics, no output directory and no registration for image. Those are over here. I haven't covered those yet. But let's go to percentile clipping, so I can get another error in there. Integration. Percentile clipping should only be used on small sets of 8 or less images. So, yeah, Winsorized clipping is what we should be using, at least from what I've read and seen, and I believe that's the default as well. Over here, I leave everything check marked that is there by default. The CFA images, I believe, is unchecked by default, but because I'm using the DSLR, I believe I have to have that checked. And I don't have any master files yet, but I'll show you that after this finishes processing where we can find those. So let's go with our reference image. Now again, we're in the subs, and the reference we renamed to ref in the beginning, so we know it's at the bottom, or in this particular case it would be at the bottom. Select it, and then our output directory. Now I'd like to use a batch preprocessing directory, and then select that so that everything gets dumped into there and doesn't mess up anything else. And at this point we can just click run. But let's do the diagnostics. Everything came back okay, there's no errors. So now let's run it, and as you can see, it's moving along. It's going to go through the bias and then the darks and the flats and create all those master files that we didn't have checked, and then it'll go through and try to register and stack the lights. So this is going to take a while. When I ran it for the 5.5-hour image that we saw earlier, that took roughly 40 minutes. So I'll pause the video, and when this gets about done, we will come back. Thank you. Okay, so this is now completed. And as you can see, the process console minimized, and we're back to the pre-processing script box. So we can close this out. Yes, should have cleared all that out, but that's okay. This took about 3 hours to complete, and yeah, 483 images that it was trying to process. 10 of them failed. I was watching the console, and 10 failed registration for whatever reason. Then that's fine. 473 is plenty of data. So if we go over here, you can see in that pre-processing working directory I have, it was clear earlier. We now have calibrated, registered, master, and the logs. All of these were created by PixInsight, and if we go in there, you can see, it had to go in and calibrate and create a bunch of copies of all the files. And registered will be pretty much the same thing. We really don't need those two directories at this point, or the logs, but for now we'll just leave it there. Let me go back into that. So the master directory is where everything we need is. So when we were talking earlier, you have the use master flat, bias, and darks. These are our 3 masters. So if I really wanted to, I could take these, since we know that they're 1 minute. The darks are 1 minute exposures. Everything's ISO 1600. I could tag those as my master and use them over and over and over again, and not have to recalibrate and re-register, which we're not going to worry about at this point, because I do need to redo pretty much everything, and I think I want to redo my flats as well. But the one we really want to concern ourselves with right now is the light. So let's open that up, and you'll see there's 3 images. Rejection high. So this is everything that was on the high end of the spectrum that it's getting rid of. So let's do a stretch on that. And as you can see, it got rid of a bunch of stuff. Let's close that out. We don't need it. Rejection low. Usually a stretch doesn't do much. You can see with the dithering and everything, and I think some drift. Once it's stacked all the images, it most of the data was in this section down here. So let's get rid of that since we don't need it. And what we're left with is the light. So let's just do a quick stretch on it. Now a lot of some people use where is that histogram transformation? No, screen transfer function, and make sure everything's linked, and use this little nuke button. Does the same thing as this little button up here, which is normally over here. I did move it over here. So basically, let's stretch this, and we've got plenty of data. Let me expand that up. And there's a nice red cast to it. Sometimes it's green. It all depends on your camera and how things are integrated. In my particular case, everything comes out red. So I'm just going to do a quick background extraction on it, but we're going to get into the ABE and DBE, so dynamic background extraction and automatic background extraction here in a minute. But just to see what type of data I have, I'm going to just quickly go through this, and here we go. So this is the integration. Here's the background. Let's see what it took away. Took away all the red cast. Let's expand this out. And look at all those nice pretty stars. This looks pretty good. So I'm going to close this out. I'm going to close this out because this is what we want to work with. Now, if we remember all the way back to my introduction video, if you've watched it, I talked about astroimaging and astrophotography. A lot of people use them synonymously. Some people like myself think of them as different. Now, astroimaging is what we've done up to this point, in my opinion. We've captured images. From this point forth, we are now getting into the astrophotography or photography aspect, where we are artists. We are trying to make it look as good as it can based on our own personal preferences and what we envision. So we are now done with astroimaging, and now we are on to astrophotography. That's how I split it up. So, but first, before we go any further, we want to take this. We know that it's already in that master file, but that master file has 3 sub-images. So what we want to do is we just want to do a save as. I'm going to go up here. Create a new folder, name it whatever you want. And what I like to do is just rename it at this point. 103. And this is my starting image. So we'll save it there. And yeah, we'll keep everything the same, default. So we're going to close that out. Now let's go into that working folder and open that up. Expand that out. Now everything is linear. So if you see this little green line over here, that means it's stretched. Okay, that means it's not the original data. It's a simulation. So we can drop that down. Okay, so we've done a basic stretch with ABE already, but let's check out dynamic background extraction on the image and see if we can get something that's better. Then we'll go back to automatic background extraction and compare the two. So let's go back into our file here and expand that back up. And let's see, we're going to open up. You'll notice dynamic crops up here. Apologies if we had some vignetting or some artifacts out here that we wanted to get rid of. We could crop at this point, but this is looking pretty decent right now. We might crop in a little bit later, but for now, let's leave it be. So I've got the module here, DBE. You can also go up to Process, All Process, and Dynamic Background Extraction. Either way will work. And here's our window. So let's go back to our notes. And as you can see here, ABE works well for clusters, and that is very true from my experience. Everything else, DBE can do a better job. It just takes more manual input. So under model parameters, my start point is 750 for tolerance. So we have no samples selected, but we're going to keep this one up, and I'll show you why later. So under model parameters, the first one here, here's our tolerance. I want to update that to 0.75, and then we can drop that down. We don't touch this one for now. Again, these are all just start points for me. Sample generation. Come back over here. So radius is 20 and sample rate is 0.4. Now if I did let me do the sample weight first. So 0.4. Now if I just did left it at default of 5 and we did a generate, you might not be able to see it on the video, but there are little crosses here, X's. So, and here is that selected sample. So let's zoom in, and right here is a sample. Look at how small that box is. So if I zoom back out, and I go to a radius of 20, and I resize all. Now there's actually a box that encompasses that X, and if we zoom in, you can see the box got bigger. And like I said, this is a starting point. We can change this as we need to. We can play with these parameters, but for most things thus far, which has been a small sampling of the images, mind you, these seem to work pretty well for most of the images from a starting point. So especially the 20 on the radius, so that we can get in there and look at the background. So at this point, I like to zoom in so that I have 2 or 3 rows of points. And let's move, let's go with 3. Okay. So at this point, this is where the manual part comes in, because we have to look at every point. So I like to go row by row here. And let's look at this one. Now if you look in, this is this one down here in the lower right, or excuse me, lower left. And if you look at the sample here, you'll see this black spot, both on the edge and upper middle. Those are actually stars. So we want to actually move this away, because we don't want to select any stars. So all you do is come back over here to the box, and we move it around until we get a mostly clear area, and that looks pretty good right there. And we do this for every point that it auto-generated. Now, if I wanted to, I could come down here. So we're going to look over here in the lower left, and it looks like a nice dark spot right here in between these 3 stars. We can just click on that and put in our own little mark. The more marks you have, the better it's going to have, better sampling it's going to have for the background, and then it'll be able to get that image the way we want it. But it's not required to do so. It's just if you want to take the extra effort to do that. Now clearly with the amount of images, or excuse me, stars in this image, it's going to be harder to find those points. But you know, it can be done. The other thing to note here, we're not doing a galaxy, but let's say we had the Andromeda galaxy in here. Any points that fell within the target structure, so the arms of the galaxy, anything of that nature, we would want to move. So at this point, was in the center of that galaxy, we would want to move it over or delete it uh, to a point where we don't have any structure in the galaxy itself or the nebulosity or anything like that. We want these points to be on the background, the black points. So let's scroll back down and let me go through this real quick. Well, not real quick, but you know what I mean. Okay, so now I'm done going through all the predefined or the generated points. I might want to put a couple more in here, but you'll notice I left 2 points alone so that I could demonstrate something. So if you zoom in here, we go up, you notice this graininess at the top. Okay, now this is artifacts due to the stacking because there just weren't as many images. It's due to that registration and stacking. So if you remember when we opened up that light file, there was that rejection low, rejection high, and on that rejection low, there was white banding along the top and the side, the right side. And this is part of that. It's all because of that drift from frame to frame and the dithering and everything. So this is where, now that I look at it, I would probably crop this down with dynamic crop to bring that upper point somewhere around this bright star right here. But we can leave it for now. What we don't want is we don't want a reference point in this area, because look at how crazy that sample looks. And if you come over here to like this point, and look how bright that looks. And hopefully in the posted video, you can actually see this up here, this graininess. We don't want to include any of that in our calculations here. So, I've moved it over here. That's a good reference point. And then we have another one here. You can see this corner is real funky. Some black points there. Let me go back down to this point over here. Where was that? This one here. And not as bad as the top, but you can just barely see, at least I can barely see some of that graininess here. So we want to pull that off the side. And let's put that up here. And, do we want to keep the stuff down along the bottom edge too? It doesn't look as bad as the top and the right side, so we're going to leave those be. Alright, let's zoom back out. At this point, we can consider our points verified. And let's go down here to correction. Now this is key. Must hit subtraction. Okay. If you just do none, you're going to end up with a single image that has what it's pulling away. But we want a second image that has everything subtracted from that. So let's go ahead and apply this and see what we get. Alright, let's do a quick stretch, minimize that. So this is what it pulled out. We zoom in, it's all the red cast on there, right? So we can get rid of that. This is the nice thing about renaming your file to your target. In some of these modules, it will postfix it with, in this case, DBE. You know, if I had done an automatic background extraction, this would be ABE. But let's do a stretch on it and see what we get. And that actually looks pretty decent. So let me undo that. And save this file. And as you can see, it's already got the DBE. Now if you notice, I'm saving after every step. Okay, this allows us to go back at any point. So let's say we get down here to denoise and it throws something out that we don't like. Well, if you notice, denoise is right here, and let's say it's background neutralization that caused the problem that later became evident in denoise. We can go back to this image in DBE, and we don't, or we could go to background noise or what have you, and we don't have to go all the way back to the original image and then redo this step and redo that step and so on and so forth. But we're going to minimize that. But for now, I think we're going to call DBE good. Yeah, we can leave that be. Let's move that up here. And let's take a look at ABE again, except this time a little bit more explanation. So the box size, let's go to 8. The default of 5 works as well. The rest of these, it just uses default. Doesn't seem to impact it too much. At least nothing noticeable that I've seen. And then again, we want subtraction and a simple drag and drop. And again, there's our background, so let's stretch that. And the red cast is gone. Let's zoom in onto the, no, that's just my eyes playing tricks on me. Okay. And let's expand this up. And stretch that. Looks kind of similar. Let's get rid of that. Let's put it over it. And so that's with the DBE. That's with ABE. DBE, ABE. The background's a little darker. Stars are a little bit whiter. This has more of a orangish cast to it. I'm not sure which one I want, so let's save this one. And yep, already renamed it to ABE. So let's save that. And let's go OK. But you know what? I'm thinking I might want to stick with, because there's just something about it that pops a little bit more for me. I don't know what it is. The DBE just pops a little bit more for me. And by pops, I mean it just hits my eye a little harder. This does look a little cleaner. Let's zoom in here. We got some noise. The background's pretty black. If we zoom in here to roughly the same size, a lot more noise. Yeah, it just didn't seem to draw out the blacks as much. That's a good question. This is one of those ones where we would go through the rest of the workflow, use the one from this one, and use the one from this one, and see which one works better. But for now, I think I'm going to stick with the DBE. So I'm going to close this one. Now at this point, we could close this, but I'm just going to minimize it for now and move it up here. And we'll pop this one over here. And yep. And what's our next part of the workflow? Color calibration. So this is 3 different modules that I've lumped into one thing here. So first one is background neutralization. We want to select a dark region of the image with no stars and make a preview. Okay, now we can do this with the stretched image. And this is the problem with clusters. There's not many dark regions. A lot of times with the galaxies, you get the galaxy in the center, but you got some dark regions out on the sides that you can really get a larger preview. And I think my best bet is going to be up. I don't want to go all the way to the top because of that banding, and I think maybe this area right here. So let me do a preview, and I'm just going to drag it right there for now. This is just a placeholder so that I can find where I think I want to be. There's a few stars in there. I don't want to go all the way up here. But again, this is one of those artistic. You're just gonna have to have a decent eye and look around and find yourself a decent spot. I know I'm probably going a little quick. But you can really see that banding right here where the noise is just up. So I really should have cropped this, but that's okay. So I want to stay away from these areas up at the top and on the right. But you need a decent darkish area, and that might be it right there. Yeah, we'll go with that little spot right there. So I know I went through it real quick. Right up here, you have this icon. new preview mode, or Alt-N in Windows. Or we can go up here to preview and new preview. Any of the three ways work. I like having the little button. And you just click that, you select it. So now you get this little crosshairs. And I want to find a spot about right here. And just click and hold. And drag it to about right there. And now this is preview number 2. And it popped out a little tab over here. So the first preview, obviously, it was just a placeholder so that I could zoom in and see what I was doing. So I can delete that now. And now we want to go over to background neutralization. Let's pop that tool up. The reference image. Could we use this as the main image? Of course we could. But you want to look at, in other, not this particular module, but other modules, you could use the main image, but the processing time, and if you make a mistake, it's wasted time. So always work on a small section. The processing time will be much faster, and then you can apply it once you get things tweaked. You can apply it to the main image. But in this particular case, the reason we selected an area with no stars in it is because it's trying to figure out that this should be our background. This should be our black points. And it wants to try to get it so that this is as black as possible. So let me go back. Let me get rid of this. So we want a reference image. Okay. Reference image is that preview that we did right here. Click this little window and select it in the drop down. Click OK. My notes don't have any other items, we just leave it be and drag the little triangle here in the corner down to our preview. So I've zoomed out, and as you can see, our preview's up here in the corner, or up here in the upper middle. And let's see, we really won't see a difference. Okay, I'm just going to drag it on here. And you really don't see a difference. If we undo, lightens a little bit. If we redo, look at these black areas like this one over here. You'll see it darken just a little bit. Very subtle. So we can close this out, but leave that preview there. Okay, we're going to need that in the next step. Alright, so let's save this and do a save as. And we're going to say BN for background neutralized. And next up, we're at color calibration. Now, undo screen transfer. So that's the nuke button we've been doing. So we undo that. Use the same preview as the background reference, but now we want to select a bright area as our new preview. Okay. have any real white points, which you would think we would. You know, everything's got this orange cast to it. You know, if it was a galaxy center, it would show up. So I'm going to put the transfer back on so I can find a bright star. And this one might work, but I kind of think I might want to use this one down here and undo. So this is our white point right here. Okay, so we want to select that. And if you note, it does not work the greatest for star clusters, but try it anyways just to be sure. So we're going to new preview. And let's zoom in a little bit more. We're going to select the star, preview 021, zoom back out. Let's do our color calibration. And again, everything's going to be default. Our white reference is going to be our second preview, which is the 21. And our background reference is our first preview from the previous step, which is preview 02. That should be everything. So now let's drag and drop. You can see everything turned whiter. So now let's put a stretch on it. Wow, that really popped. So now let's hover, undo, orange cast, nice and white. You know, my note said it doesn't always work the greatest, but I kind of like it. So we're going to leave it. So again, we're going to save it. Except this time, we're going to postfix with color calibration. Now let's go back to our notes, and now we have photometric calibration. And this is where we need to know our rig setup. What is our pixel size and what is our focal length? And ensure that we are not nuked. The screen transfer function is not active, so we want to undo that. Let's go into photometric color calibration. Now the first thing I'm going to want to put in there, what's my focal length? Right here, 1960. And my pixel size is 3.72 microns. And I've always just left the white reference as the average spiral galaxy, irregardless of the target. Just seems to work. The database server, there's only one in the U.S., or there's two in the U.S. I'm on the East Coast, so I'm going to go with Cambridge. And now I need to search for the coordinates. So, I need to search for the target, which is under the search coordinates. And this is M103. And it found it, object M103, OPC for open cluster. And all I have to do is do a get. And it populated the information here. The observation date, that was 2018. Usually I don't have to change this, but let's try that. All right. And this time it worked. So, yep, that's done. And you have the nice little white balance function graphs. I don't fully understand what it's telling me here. Definitely something I'm going to have to read up about at a later date and time. But most everything is pretty close to that line with a few outliers. So let's close that out. We don't need this anymore. And let's get a stretch and see how it looks. So, a couple of our stars are oranger, some of them are whiter, maybe a little bluer in some spots. You know, looking pretty decent at this point. So at this point, I'm going to close or delete my previews. Going to save. So this is photometric color calibration. All right. So this was, so let's just take a look at what did it do. So this was before, and this is after. Kind of washes it out. But like these stars here kind of have a greenish tint to them. Oh, that was color calibration. Okay, so yeah, we're going to leave it the way it is. So we're done with photometric color calibration, and we're going to move on to deconvolution. So what do our notes say? First, we have to make a mask. All right, so to make a mask, it's a luminance mask. Now, if we were running a monochrome CCD with filter wheels, we would probably have a luminance filter, which, luminance filter basically allows pretty much all light through. It doesn't segment the photons by wavelength. So RA, H alpha, red, green, blue, oxygen, sulfur, all those different ones that we would be capturing if we were using a filter wheel in a monochrome CCD. But the luminance filter allows pretty much everything through to hit the CCD, which creates the brightness of the image, the luminance. So what we can do, since this is a DSLR, essentially a one-shot color camera, we don't have a luminance filter, we can create a synthetic luminance. that with this little button right up here. Extract CIEL star component. That is our luminance. And it has an underscore L. And if we stretch that, as you can see, it's a simple black and white. Now if we move it off to the side here, this star is yellowish, and it's white here. It's simply a grayscale image. So I'm going to minimize this real quick and move it here. So this is our luminance image. So we've made it. Now we need to clone this. And cloning is real simple. We just come over here to this tab, drag it over to our empty workspace, and release. Now we have a clone. And you can see it up here, it says clone. Go back to our notes, and we rename that as decon mask. So to rename it, we just come back over here to this tab, double click on the tab. I simply rename it. I replace the clone with decon mask. And click OK. And then we minimize it. Now everything up to this point, if you notice, I've been using this little triangle with the bar above it to shade. And it creates this nice little box. We can drag it, it snaps into place. You know, that works great for this stuff. But in this particular case, I just want to use this dash, okay? Iconize it. Now there's a reason why. It doesn't snap into place like the others. But it gives me the full name here so that I can see that decon mask. I could have replaced everything and all that, but this is my workflow. You do what you need to do to make your workflow work for you. But in this particular case, it allows me to look at, you know, it knows that this is a working image rather than a static history, and I can see the name. So that's just a little sidebar. So now, we've minimized that. Now we need to create a star mask from the luminance image. So we're going to just use the default options, but tweak a couple settings. So now we come over here to the star mask module. As you can see, it says star mask, so that would be up here, processes, all processes, star mask. And my notes say leave everything default but two settings. The first setting is truncation down from 1 to 0.9. So there's truncation. I'm just going to change that to 0.9. Now again, these are starting points. Okay. Might come back and revisit this later and change these up a little bit, but for now, for most things so far, these are what worked. And the shadows 0.01. So there's our shadows, and let's change that to 0.01. And all right, so now we just apply it to our luminance mask, or luminance image, I should say. And there we have our star mask. So I'm going to get rid of this. Drag this over here. Stretch it. As you can see, detected the brightest stars, left the smaller ones alone, and just created little round bubbles around them. So our note said we can minimize that. Again, I'm going to use this little guy right here. I'm going to put him right next to the decon mask. So now we want to open dynamic point spread function. So let's open that up. It's that PSF right here. As you can see, dynamic PSF. That is up here in all processes. Dynamic PSF right there. Now, to clear all this out, I haven't seen an easy way to do this except for go up here to the top, select the top one, and remove. That clears everything out. So what do our notes say? Select at least 5. 20 is preferred. That's 5 stars. 20 are preferred. All should be between 0.8 and 0.2 amplitude, and that is the A column. So let's look at that. So let's zoom in. If you notice, it says no significant data. That's because the star is too large. So let's select this little guy here. Alright, so it's a Moffat. And the other thing we're looking at is this A column, 0.4. So that's the amplitude. So I'm going to move this off to the side. So we want to pay attention to this column here. And we want to make sure that is between a 0.2 and a 0.8. Essentially, a 1 is saturated. So we don't, when you look at a point spread function, it should look like a cone. Okay. So when you're looking at the point spread function, when you're looking at the star, you got this nice round bottom area here. That's what you're seeing. You're seeing this, right? But in reality, it's a little bit lighter at the, or darker at the edges and gets brighter towards the center, just like you see here. And in reality, this is what, this is what you should be seeing right here. Okay, so this is more of a 3D view of the 2D images we're looking at. Okay, so when you hit that 1, this is a 1. If it was 1.1, now your top is going to be flattened. So we want to make sure, let's look at our notes here. So we want to make sure that the stars are Moffat. Okay, those are preferred. We can go Gaussian, but we want to try to get as many Moffats as we can. All right. Now, if you noticed, like if I select this one here, nice and bright, again, no significant data. But this guy here worked. So if I select this guy, it's a 0.3. Why do we have no significant data? Look at this box right here. Okay, if I zoom in, the star fits inside the box. If I tried to use that one, the star is so bright and so washed out that the box encompasses the star, so it can't find the edges. It can't find that little peak. Okay, now the other thing we want to look at is, see how this star encroaches on the side? We kind of don't want that either. But this star field is just so populated that we're going to have a hard time finding appropriate stars that aren't like that. But let's try to find some. So let me clear all this out. And we're going to, I just like to start up here. And let's start with this guy as our first one. If you see, he's a 0.09. He's a little too dim. So we're going to remove him. 0.08. And this is just where we have to hunt. Alright, so 0.36. That's a good candidate. And do this enough times, you're going to start seeing the pattern based on how far zoomed in you are. These two are not good. This guy's good, so we need something a little bit brighter than this guy to about this guy. So we just scroll across and we start picking the stars. Okay, at this point, I'm just going to stop for a second. As you can see, I have 5 of 5 selected. Now, if you remember my notes, minimum 5, 20 is preferred. Could I do a PSF right now? Yes. But all of my stars are in this top section. We want to get more across the board. Okay? That way it can generate, the more data it has, the better PSF it can generate. So let's continue on and see what else we can find. Alright, so we've got 20 stars. And let me pull this back over. And down. So if we scroll through this, I'm looking at the amplitude as well as the type. And even though as I selected a star, I was checking it, I always like to go back and double check it just to make sure. So everything is Moffat and everything is above a 0.2 and below a 0.8. So let's go back down, move you over, and now let's just click the camera icon and we create yet another image. Camera icon is this little guy right here, and it creates a synthetic PSF image for us. At least that's the theory. So if you notice, it didn't do anything. Why? Because it only had one selected. So I usually highlight one, Control A on Windows, and now you see 20 selected. and collect it. Oh, and it was behind there. Now, if we zoom in, this was our first guy, and this is our second guy. This has more detail than this. So always ensure you select all your stars and not just one. So we're going to close him, because if you hover over the box, the very bottom, fitted functions for the selected star or stars. So what was an error in my part by not selecting turned out to be a teaching moment for all of us. And now I'm just going to minimize him and put it right there. And I'm going to close that out. Alright, so now we need to apply the luminance mask to the image. So this was our luminance image, and this guy is our real image. So to make it a mask, all you do is drag it and not onto the image, but down here onto the little sidebar. And now we have it as a mask. Do not close this. Just minimize it. If you notice, nice red area, excuse me, area. So if we invert the mask, now everything is, the centers of the stars would be protected, and bring it back. So anything in red is going to be protected. Anything not in red is going to be edited in the next step. But we can turn off that mask. Now if you see the orangish tint to the tab here, that we, if I reopen this, you don't see here, so let me drag it over. See how this one's gray and this one's orange? The orange indicates that there's a mask applied. So now that we've applied that, we need to open deconvolution, which is right here. And that is in processes, all processes, deconvolution. So all that work to create these 4 images here and apply a mask is what this is about. So we're going to come up here. We're going to go to external PSF. This little tab right here. And the view identifier. Okay, so that little PSF, we took the time to select the 20 stars, create our little PSF. That's what we want right here. Could we use default and tweak and guess? Yes. But we have stars. Why not create a PSF from the data we have so that we have a customized PSF for this image? Our next thing is 50 to 80 iterations. That's in this one right here. The more the better, but not always. You know, I always like to start with 80 and then see what happens. If I need to go more, I will. If I need to go less, you know, again, that's all your eye, your personal taste. So now we open up a preview to work inside. So we go back up here, new preview, just a small segment. Let's select it over here. And anything we had here in the main image will be in this preview. So if you notice, it's got the orange bar. It has a mask. Has the same mask. So you're keeping all of that intact. You're just working on a smaller area without doing anything destructive to the main image. And now we need to make sure we don't have any ringing on our stars. So that is this little checkbox here. Let's expand that down. So for dark, start around 0.04. That's this guy right here, 0.04. That's where I like to start. Use the star mask for the local settings. Local deringing. Local support is our star mask that we made earlier. And apply to the preview after every change. So as I would make any changes, I would apply it to the preview. So let's see what happens. Drag and drop. And as you can see, it's going through the 80 iterations. And when we get to doing the main image, you'll see this goes much slower. Alright, so if I zoom in, I don't see any ringing in the stars. That's a good point to start. Right. So if I come up here, yeah, there's just not much we can do. So let's go to a 0.1. Let's see what happens with a 0.1. I'm still not seeing anything here. So let's go to a 0.2. If you notice, I really haven't touched any of these down here because this is stuff we'll get into later on and some of the other modules, so I really don't touch them at this point. Let's see what a 0.2 does. Well, the 0.2 really doesn't do much either. I'm going to go back to 0.04. Whoops. 0.04. And now let's adjust our wavelet layers to 5. Let's apply it. Okay. Not seeing any ringing in the stars. It really doesn't do anything to the noise, simply because we have the mask applied. I'm going to close this one. And I'm going to select a different area for my preview. double check this one. Alright. Doesn't seem to be doing much, but it is doing something even if it's not immediately visible to us. So we like this, at least I like this, so we're going to apply it to the image as a whole. And before I do that, before I drop it, we'll notice a difference in how long it takes each iteration to do. If you notice before it was bing, 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 all the way through. Now, you're on the larger file, it's taking longer. So we'll be back when this is complete. Alright, it's done. So let's undo. Let's see if we can see the difference. Doesn't look like much one. Doesn't look like much of a difference, but I'm sure it'll pay off in the end. But the image is looking pretty decent at this point. So let's close out deconvolution. And where are we at? So now we got a denoise. So let's save as. Decon. Okay, so now we're going to move on to denoise. So we've left it. We've left the mask attached to the image, and now we're going to invert that mask. So we're going to go over here, show, and invert. So we're keeping the points of the stars intact. We're going to try to remove some of this noise. Let's see if we get any good results here. So we're going to open denoise, which is right here, which is kind of a, we call it denoising, but they call it multi-scale linear transformation. And we are going to use 3 of the 4 layers, and my starting points are these 3 values here. So we need to highlight the first one, select noise reduction 3, 0.33, and 3. Our next one is 2, half, and 2. So we select the next one, noise reduction 2, 0.5, and 2. And then our third one is 1, half, and 1. 1, half, oh, nope, that's a 2. Forgot to select. So this will be a 1, half, and 1. And then test on a preview image, and when happy, apply to the image. So let's do a preview. First, I want to not show the mask. Let's look at the preview. And see what it does. Looking at this area right here. See if that smooths out any. It did smooth it out quite a bit. we can undo, and paying attention to this area right here. Let's undo. Oh, big difference, big difference. I hope you can see that in the video. Very grainy, lots of noise. If we redo it right now, see how it just smooths that out. I'm gonna undo it, and on this third one, I'm gonna bump that up to 0.75. Maybe not such a big jump. Let's go to 0.7. Let's see what happens. Smooth it out pretty well, so let's undo, redo. And I'm just toggling between them, looking at the stars as well. You can see these little diffraction spikes right here. I hope you can see that. So when I redo it, they get kind of blended away. I'm not sure if I like that or not. I'm going to go to a 0.6. Undo. Let's try it again. Now, a lot of people, instead of using a small area like this, they use this little button right here. But let's look at this before I get into that. Undo, redo, undo. You know, I kind of like that. So back to this, they use this little preview thing here. So if I go back here and I use this preview, it opens up. It should pop up here. Now you kind of see the problem. Anytime you make a change, right? This little wheel up here is spinning. It takes a little bit for it to update. And if we were going in here and doing a lot of these other things we can do in here, you know, this might be good because we can see things on the fly as they happen. You know, but having that update time and everything, just, I don't like doing it. I like working in a small preview window where I can come up here and use this little button here and undo and redo and undo and redo and just see. It just seems to be a little bit faster for me. But that's me. So we're gonna go back to this. We're gonna close out our preview. We're gonna make sure the mask is inverted, and it is. And we're gonna apply it to the whole image. And this will take a bit. Alright, it's done. We zoom in. That noise is nice and smoothed out. Let's look at that top edge. We still have a lot of that. I really should have cropped that out in the beginning, but that's okay. we're going to think we're done with that, so we can remove the mask. Image, let's see, remove mask. We're going to save that. Denoise. And I keep saying I should have cropped that out, right? So if I really wanted to, I could go back here, and this was our starting point. So I could go all the way back there, and I could crop it and redo all these steps. But I'm not going to do that right now. So we're going to close out this. And what's our next one? Linear transformation. Okay. So everything up at this point, we've been using the file in its linear state. And now we're going to, for lack of a better term, convert it to a nonlinear state, which will be close to our end. So let's go over here. What do we have? Linear transformation. So we want to stretch the image and apply that to the histogram. So we're stretched up here, right? But we really can't do what we need to do with it like this. So we're going to unstretch it. Then we're going to go down here, and we're going to open up these two. Screen transfer function and histogram transformation. So if you remember from earlier, this little nuke button, when everything is linked, is the same as this button right here. But we need to use this. Okay, so what we're going to do is we're going to select our image. So we don't need the rest of these. So let me get rid of these so I don't clutter up my menus. Yes. All right. So now, I think that's it. Yep. So now let me move this back over here. And what we're going to do is we're going to open up this guy here. Select it there. And we're going to select this guy. And then our STF, and we're going to nuke it. That looks a heck of a lot brighter than what this up here had done, right? Well, don't worry about that. We'll fix that. So we're going to take this little triangle, and we're not going to do it here. We're going to drag it all the way over here to this guy. And bam. So now we're going to unstretch this. We're going to minimize that. And now we're going to work inside here, right? Now we're going to work in this little preview, right? Oh, wait a second. Okay. Yep. So now we're going to unstretch. Whoops. Okay, so we did unstretch the image. But in the preview, we're going to play with that histogram, okay? So we're going to be paying attention to this guy here. We're just going to zoom in so we can see these 2 points here. Now if you notice, we're clipping some stuff here. This first value is what we're clipping. So we don't want to clip too much, but we do want to make things pop a little bit more. So we're just going to play with this little slider, right? Now see, if I move it there, it turns real dark. But if you notice, we're clipping 71 million pixels. We don't want to do that. But if we do here, we're clipping nothing, and it's very whitewashed. So we just want to drag that back over to the point where it's kind of black. And this is where we have to go with what our eyes tell us. You know, that looks like artificial black sky to me. I don't like that. Right? Then we can play with the middle slider. We can bring it across a little bit. Tighten it up a little bit. And, you know, this is where we really have to get artistic with how it's looking. You know, I obviously don't want to whitewash it. But I don't want it to look fake either. Thinking somewhere in there. Then we can come all the way over if we wanted to try to bring down these whites. But I just don't see. I usually don't have much success using this white pointer over here. So let me go back over. You know, I kind of like it like that right there. My personal taste, my personal preference, I would kind of like it. So I can close the preview and apply it to the image. So let's close the preview, because this is the linear format. This is where, you know, this is what the image looks like. And now we're going to take it to nonlinear, and bam, there we go. So we can close this out. We can close this guy out. And that, yeah, I kind of like that. We'll leave it right there like that, like it is. We're going to rename it to LT for linear transformation. And next up, high dynamic range. Okay, so HDR, we'll select that. So that's a HDR multi-scale transform. That is up here, and it's right there, or HDR, excuse me, right there. So we again, my notes say, let's pop it up here, just use the defaults. So let's just go ahead and apply it to the image. Yeah, let's see if it made a difference. Oh yes, most definitely. If you watch this star right here, watch how it shrinks just a little bit. Yeah, we'll leave it there. Nice and soft on the background. Yep, we'll leave it right there. So we're going to close this out. And we'll save this. And this is where saving those files along each step comes in handy. Let's say I didn't like that it faded out these brighter stars as much with the way I did the background here in the linear transformation. I could go back to the file right beforehand. I could go to this file right here, open it up, redo my linear transformation, and try to get something that might work better with the HDR. So otherwise, we'd have to go all the way back here and redo all this. So it's a good example of why we want to save after every step in our process. Yeah, it gets a little tedious, but it's definitely worth it in the long run. But I actually kind of like what it did here, so I'm going to leave it be. So next in the workflow, and will probably be our last thing, is detailing and sharpening. Okay. So we need another luminance mask. If we remember, we just go up here to this little button right here. Expand that out a little bit. And if you really wanted to, where was that at? Extract, under image, extract. We could do it right here. So if we go back to our original image, go image, extract, lightness. But I find it easier to use this little button right there. So we have our luminance mask again, and it says that we need to protect the background so it will not be inverted. So we're just going to let me make sure. Yep. So I'm just going to apply it to my image. I want to minimize that. Let me show the mask. And you can see that the background will be protected. So let me do not show. Now we need the LHE, local histogram equalization. So that is this module right here. Process, all processes, local histogram equalization. So what do my notes say? I like to use 2/3 on a mount. So it's roughly 0.666. Let me open up a preview. See if it does anything. It brightens the star a little bit. Makes them pop. Alright, so we're going to close that preview. Bring it over here. And let's see what it did. Just makes the image a little bit brighter. But only the stars pop out a little bit more. Alright. So now I can close that out and remove my mask. Now I want a star mask. So let's go back into this guy. Noise reduction above the noise levels. Okay. So we go down here. And again, we want to concentrate down here. Okay. We want to look at these values and hover over the dark areas. As you can see, they're around 0.1, 0.11. So I'll probably go to a 0.12. There's a 0.12 in the blue. So on the noise reduction, or noise threshold, excuse me, we're going to go to a 0.125. I want to go just above the values I'm seeing, but not too far above. So like there, I saw 0.1207, 0.1259. Maybe I could go to a 0.27. Let's go to a 0.127. Okay. And then scale should be around mid-range, 6-ish. Played with this, and if you go too much, we'll play with that here in a second, but things could get real bad real fast. And then structure growth, start at 0, 0, 1 and tweak it. Okay, so 0, 0, 1. Oops. 1, 0. So again, we want to work on a preview. Let's see what happens. You know, it doesn't look too bad. But let's minimize that. Now let's go up to an 8. And let's do the same thing. As you can clearly see, these are a little bit bigger. So let me move this over. And let's go down. We had a 6, but let's go down to a 4. Let's do that again. We're kind of shrinking the stars, possibly. So this one, so this was a 4. This was a 6. And that was an 8. Now, for this, I think I'm going to leave the 0, 0, 1 here in the growth. But as you can see, 4, 6, and 8, those are our star masks. I think I'm going to leave it as 6. I think I'm going to leave it as 6. you know, a 5's going to be in between there, and a 7's going to be in between there. I think I'm just going to leave it a 6 in this case. So we're going to go back over here, put this back to a 6. Delete my preview and generate the star mask. Alright, there we are. So put that over top. As you can see, the really bright stars, like right in here, they're not included. So we will minimize that. Don't think we need that at this point. But let's create a new luminance mask. I always like to start fresh with after anything we've done. So this is the new luminance mask. And we're going to apply it. Again, we're going to be correcting. We're going to be protecting the background. So we show the mask, we're protecting the background. And now we're going to be shrinking the stars. So that is this module right here, shrink stars. We can get rid of this. I don't have any notes on here, but what I have done in the past is I changed the size from 3 to 9, and then I go with this guy right here, circular structure. All right. And I think I was supposed to apply this. As well. Show mask. Yes, so I'm protecting the background. Okay. Alright, so I need to update. Let me remove the mask. Remove the mask. I think it's this guy I need to apply. I think I need to update my notes. But we have both of them, so let's see what happens when I do it this way. And didn't seem to make that big of a difference, did it? Oh, yep. Toned it down just a little bit. See how they got fuzzy on the edges? So it just tones them down just a little bit. This is where we can apply some different things, but I think we're okay here. But let's go back to the original. Let's remove that mask and let's do the luminance mask. You know, this is one of those things where you just have to play to see if it gets you something you like. And that toned it down a lot more. Brought out some of these spikes here. Yeah, I like that much better. And then what we can do is remove that mask. Then we can apply this mask. And let's apply it to that. It softens them up just a little bit more. So let's zoom in. Undo. Yep. I actually kind of like it like that. Our brighter stars pop more. The more distant, fainter stars are just that. They're fainter. They look more distant. It really focuses your eye into the center here, which is M103. So I'm going to remove that mask. I'm going to save it. Details. Okay. Now at this point, I have saturate and contrast. So this is where I would convert it to a TIFF and then bring it into Lightroom or Photoshop and play with some of the tools inside there. If it was a galaxy or a nebula, try to bring some of those dust lanes out or what have you. But, you know, this is an open star cluster, so we really don't need to do that. So at this point, I would just be exporting this as a TIFF and a JPEG. But I want to see side by side okay. So this was my first attempt with 5.5 hours worth of data using this workflow, and it just looks more cluttered. I do know that in this particular instance, I used ABE instead of DBE. And then we have this guy here. But just for comparison's sake, first thing we want to do is do a TIFF and save. And we'll leave it default. And then we'll also, so did it save it as a TIFF? Yes, it did. As a JPEG. And yes. course, we want to go 100%. Okay, so we're going to minimize that. And this was the first attempt. Now we're going to go back. Go with JPEG. That way the file formats are identical, just in case there's any processing differences. And that just looks cluttered to me on the first attempt. Second attempt, it just, bright stars pop a little bit more. The attention's drawn to 103. Gives more depth. There's more sense of depth. I could probably go into Lightroom and bring these, adjust the lightness a little more so that they're not so faint. But I actually like this. I think I'm going to call this one my final for 103 until I get better at using PixInsight and improve my workflow. Let me know in the comments. What do you think? Do you like the original better or this one? Beauty's in the eye of the beholder, and I like this one. It just looks more natural to me. So, yeah. I think that's it. So with that, let's just take a gander at it. Let's go in here and let's look at it full screen. Yeah, that works for me. Yeah, I like it. We'll keep it. So with that, I hope you enjoyed watching this workflow. And if you're hearing this, clearly it's at the you've watched the full-length version and not the individual chapters. I believe there's going to be 11 or so. But yeah, we're now done, and I hope this helps you out. It definitely helped me out to put everything down on paper and paper, Word document. There we go, and getting everything as concise as I can. I do have to make a couple updates to my notes, especially in regards to the star shrinking. But I like what we ended up with, and I really hope this you found something in here useful, and that your images turn out better than mine. If I helped you get over some little hang up you were having, and your image ends up turning out better than mine, then kudos to you and congratulations. This is a lifelong hobby, and as technology grows and the software gets better, our images will get better, and it just amazes me how things can progress. So with that, I'm going to wish you a good rest of your day. Thanks for watching. If any of this helped you out, or you found it interesting, please hit the like button, subscribe to the channel, click that little bell so that you get notified when I post something new up there, and I'm going to wish you clear skies and good day.